Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at derangements. So a derangement is an ordered arrangement such that no object is in its original position. We denote the number of derangements from n objects like this. So we have the factorial symbol before the n. So let's go through an example and hopefully this will become clearer. So let's say I take the hats from 3 students. I then give each student one of the hats at random. Calculate the probability that no student receives their own hat. So let's write out the number of possible arrangements for this. So I'm going to write the arrangement 1, 2, 3. That means that person 1 got hat 1, they got their own hat, person 2 got their own hat, and person 3 got their own hat. And then I can have, say, 1, 3, 2. So this means person 1 got his own hat, but person 2 got the hat of person 3. Person 3 got the hat of person 2. These two swapped hats and so on. Now we know that the total number of possible arrangements is 3 factorial, which is 6. So there are 6 possible arrangements. So let's find out which of these are derangements. We want the ones such that no object's in its original position. So here, 1, 2, and 3 are in their original position. Here, 1 is in its original position. So neither of these is a derangement. In this one, 3 is in its original position. It's not a derangement. But here, 2, 3, 1, none of the objects is in its original position. Same here, 3, 1, 2, that's a derangement. None of the objects in its original position. This last one is not a derangement because 2 is in its original position. So in our hat problem, these are the 2 possibilities such that no student receives their own hat. Here, person 1 received the hat of person 2, person 2 received the hat of person 3, and person 3 received the hat of person 1. So the answer to this question, probability, there's just 2 ways it can happen over 6 outcomes in total. Remember, when all outcomes are equally likely, the probability of an event is the number of ways it can occur over the total number of outcomes. And that's why combinatorics are very important in probability. They help us count this and count this. Now this was easy because there were only 3 students. It was pretty easy to write out all of the possible arrangements and derangements. But you can probably tell if we had, say, 30 students, it would take forever to do that. We need a quick way to calculate it. So the quick way we can calculate, we take our number of derangements, we take the number of arrangements, and we divide by the number E. E is about 2.71828. So this will usually not give you, well, almost always not give you a whole number. So here we have kind of the floor and the ceiling function. You just round this to the nearest whole number because the number of derangements must be a whole number. So E is just a button on your calculator. It's okay if you don't fully know what E is. You can still input it into this formula. All right, let's look at another question. So there are 10 students in the class who complete a test. Each student is randomly given one of the 10 tests to mark. We're going to calculate the probability that exactly 1 student receives back their own test. So the probability of an event is equal to the number of ways it can occur over the total number of outcomes. So if we are taking 10 students' tests and randomly giving them, randomly distributing them amongst the 10 children, the total number of outcomes will be 10 factorial. That's the total number of possible arrangements. So how many ways can we have exactly 1 student receiving back their own test? Well, there are 10 choices as to which is the student who receives back their own test. And for the other 9, we want to make sure they don't get back their own test. So we want to count the number of derangements of 9 objects, in this case 9 students. So remember what we do to calculate the number of derangements. We calculate the number of arrangements and we divide it by E and round this to the nearest whole number. So when putting this on our calculator, we need to do this part first. So 9 factorial divided by E is about 133,496. That's rounded to the nearest whole number. And then we put 10 factorial on the bottom. So now you can put it in your calculator just like that. You get about 0.368. So there's about a 37% chance that exactly 1 student receives back their own test and the other 9 receive back someone else's test. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.